Hello and welcome to this presentation. My name is Isaac, I am a PhD student at Utrecht University and I will be describing our work. Order out of chaos, construction of knowledge models from PDF textbooks. I will start by saying that textbooks are high-quality textual resources, but they are often considered to be non-structure. But, if we look carefully how textbooks are made, they provide a lot of information. The table of contents provides browsing aid, and the index provides searching aid and terms in the domain. The authors use their understanding of the domain while creating textbooks, and we use these formatting and structuring conventions to extract meaningful information. Our goal is to achieve the automated extraction of machine-readable textbooks models. This goal involves two research questions. First, can knowledge be automatically extracted from textbooks? And second, what would be the quality and the value of such models? Our work seeks to answer these questions. We developed a rule-based approach for the extraction of the knowledge models. We focus on PDF as the most common and challenging digital textbook format. Our workflow has 4 stages, 9 steps, and 39 rules. The modular nature of the rule-based approach supports its gradual refinement. Each time we encounter a new variation of a formatting or structural pattern, we extend the approach by modifying an existing rule or adding a new one. In the diagram we can see the complete workflow. The first stage is the text extraction to reconstruct all the words, lines, and pages from the PDF. In the second stage, the workflow assigns role labels, such as section heading, subheading, important text, and body text, to each text fragment. This process facilitates the subsequent recognition of different logical elements of the textbook. The third large stage of the workflow is to recognize all different logical elements within a textbook. First, auxiliary elements such as page numbers and headers are filtered out. Then, the individual entries of the table of contents are recognized and processed. Later, each index term is identified. Finally, individual sections are recognized. In the final stage we construct the textbook model, which can be later enriched with external information. To give you one example of how the rules look like, we have the repeated lines rule, which is used to detect general page header and footer. This rule is part of the auxiliary elements filtering step. First, we create a sample of continuous pages from all the pages in the textbook. Then, if the first lines in each page of the sample are the same, a header is detected and removed in all the pages from the textbook. Footers are detected in a similar way but comparing the last lines in the pages from the sample. The rules are used to identify different elements in the textbooks. In the table of contents, we use them to detect the pages that belong to the top, non-content sections like notation or preface, chapter and subchapter entries, entries that are split in multiple lines, and to identify one of 3 possible types of TOCs, flat-ordered or indented. For the index sections, the rules identify the pages that belong to the section, the heading and page references of the terms, multi-line terms, different types of terms like cross-references, and nested groups of terms. At the end of the workflow we construct a textbook model using the Text Encoding Initiative, which is a standard for digital representation of texts. In the model we group the information in 3 categories: structure, content, and domain knowledge. The structure section contains the name and precise start and end page of each chapter and subchapter of the textbook. The content includes the textual information structured as words, lines, fragments, and pages for each chapter and subchapter. Finally, the domain knowledge contains all the important terms in the domain extracted from the index section. To test the accuracy of the extraction of the models, we extracted the models using our rule-based approach and using the EPUB version of the same textbooks. In the EPUB textbooks the information is already structured and marked, so it is easy to extract and it is accurate. We hypothesize that if the information obtained from the 2 versions of a textbook matches, that means the approach processes PDF correctly. We used textbooks from 4 different domains: statistics, computer science, history, and literature. Results from this first evaluation show that our approach has high accuracy. For the text extraction aspect, we also compared our approach against two other tools as baselines. Our approach achieved the highest similarity, followed by PDFBox and then PDFAct. We don't reach 100% similarity mostly because of formulae, charts, and tables that are images in the EPUB but text in the PDF version. An additional effect of the rules that improve textual extraction, along with the rules for recognition of page, is a cleaner textual version of the textbook, as seen when our approach is compared against the out-of-the-box PDFBox tool that lacks these features. For the recognition of the individual entries in the table of content, we reach a precision and recall of almost 100%. Precision and recall are also very high for the recognition of the index terms. We also study one of the possible knowledge-driven applications of the extracted models. We used models of two textbooks to cross-link relevant sections. The idea is that any chapter or subchapter from the first textbook can be linked to any chapter or subchapter of the second textbook to identify similar sections. We constructed a linking model using a term-based vector space model (VSM) with 1,611 terms from the two books. Then, the VSM was applied to all chapters and subchapters of the both books. The sections have been annotated by the terms according to the knowledge models extracted from the textbook's indices. The inner product of these annotations has been used to compute similarity between all sections of Book 1 and sections of Book 2. We use the normalized discounted cumulative gain to measure the quality of the ranked documents by relevance. NDCG at 1 measures the effectiveness of retrieving the most relevant document, while at 3 and at 5 measure the capability of the retrieval system to find the first 3 and 5 most relevant documents, respectively. We also used a manual linking produced by experts as the ground truth for the NDCG measures. Finally, we used two baselines for comparison, the standard TF-IDF model and ALDA model. Both baselines have used the textual content of each part of the textbooks with basic preprocessing, lowercase, stop words, and stemming. The results show that the proposed model consistently outperforms all baselines, as seen with the yellow bar in the graph. The difference between our model and the baselines is the highest for NDCG at 1. The semantic information placed by the authors of textbooks in the index sections and extracted by our approach helps our linking model find 72% of best possible matches between the textbook sections. As the number of potential matches increases, the difference between NDCG scores diminishes due to the ceiling effect. As summary, we developed a rule-based approach that allows the automated extraction of knowledge models. This answers our first research question. Our first evaluation experiment shows that the approach is capable of processing PDF textbooks with high accuracy. And the linking of section across textbooks within the same domain demonstrates the added value of the extracted models. The two evaluation experiments answer our second research question. Related to this work, we have taken individual textbooks within the same domain and integrated them with each other and with the linked Open Data Cloud using DBpedia. For example, individual terms like mean and Venn diagram are linked to their corresponding resources in DBpedia. Also, our rule-based approach is the foundation for InTextBooks, a system capable of transforming PDF textbooks into intelligent educational resources. As future work, we plan to use the information in both the table of contents and the index more extensively. Each chapter, subchapter can potentially be treated as a topic, subtopic annotated with terms in the domain thanks to the explicit connections between the terms in the index section and the different content sections. Finally, I invite you to check out our GitHub project, and to use our web service to create textbooks models. Thank you for your attention.